Thank you for coming this late afternoon. So we are talking about federation, and you might wonder yourself why we talk about federation in the framework of the Human Brain Project. Of course, you work collaboratively, and it suggests itself that this has to do with federation. And within the Human Brain Project, we had a project that was a parallel running one called IC, and this was finally in the framework called Phoenix. This is a bottom-up initiative by some centers, by today 6 centers, you will see. And in order to understand where all this came about, we need to enter our time machine. And let's go back with our time machine to the year 2016, I guess. Yeah? Please.
Hi Maren, hi Anne. Have you heard that we need to plan another EU project?
Hi Anna. Yes, Thomas mentioned it to us. Does any of you know more? What is it about?
Hi everyone. I think it's related to the infrastructure for the Human Brain Project.
Yes, exactly. We've had a brainstorming with Thomas and Dirk the other day. A special call just for the HPP is going to open soon. It is designed for funding procurements, so new hardware and customized software for e-brains.
Cool. So what's the plan?
So the HPP urgently needs a data infrastructure. So storage and related software services to move and transfer data, and it needs to be well connected to computing resources to be useful, of course.
But just the data infrastructure isn't enough. One of our colleagues has done a use case analysis. We also need some cloud resources. There are so many services under development which need to run somewhere. Currently, there's no real home for them. It's important that such virtual machines can then also access our large storage resources.
Yeah, not to forget about some cluster resources as well for modeling, simulation, data analysis, AI jobs.
Okay, sounds great. Where should it be located? It would be great to have such resources at multiple sites, yet alone because the HPP data is spread across some of the HPC centers of the HPP already. Some groups also already have HPC allocations at their national HPC centers.
What about inviting all 5 HPC centers in the HPP to participate?
Oh, great idea, let's do that. But how should we call that infrastructure?
So Thomas suggested Phoenix, the Phoenix Research Infrastructure.
How will the access to the resources be managed?
The European Commission says that programmatic access for HPP and other European communities is an option. But of course, they need to follow similar principles as in PRAISE. So with excellent-based independent peer review, a technical review of the proposals, for example.
Okay, in that case, we also need a service to manage users and resources. The Phoenix User and Resource Management Service, FRMS.
Yes, and we need a federated authentication and authorization infrastructure, of course compatible with the HPP AAI.
Okay, so let's collect what we need. So starting with active and archival storage, cloud resources and cluster resources for scalable and also for interactive jobs. Those all need to be tightly connected. And of course we need federated AAI and firms compatible with the plans of the HPP and eBrains. Maybe also some more federated services. Sounds like a plan. Let's try to meet with the other centers and start planning.
Yeah, thank you. So let's transform us back into the year 2023. And now we are here. And let's discuss what we have done over this time. Thank you very much. Oh, yeah, you are not ready. You are not yet ready. Okay, then let's go back to 2016 again.
No, we're now in 2023.
Now you are in 2023. Okay, fine.
Yeah, hi there. I was thinking the other day about our brainstorming from some years ago when we started to plan Phoenix with Thomas, Dirk and the HPC centers.
So much has happened since then. Now Phoenix actually exists.
Yes, indeed. And there are so many different interesting and important user groups. Do you know how many projects we have had?
About 80 from the HPP and neuroscience community, and about 80 also from other scientific communities that received access via PRAISE.
Oh wow, what do they do?
Oh, there's a lot of variation. Some projects mainly need cloud resources to run their services. For example, the collaboratory, the knowledge graph, Atlas viewers, the neurobotics platform. Some of these services even spawn jobs on the clusters.
Others mainly focus on the usage of the cluster for modeling, simulation, or data analysis.
And some projects really just need some cloud resources for the participants of a training or a workshop.
Oh, so much diversity. I can't believe that we're already almost at the end of the HPP and at the end of our IC project.
And not only this, there are also impressive achievements related to the research and development service procurements in the IC project. For example, the data mover service. It enables data transfer between different repository types, which is a unique worldwide activity.
Indeed, and the Phoenix User and Resource Management Service, which is the first of its kind with respect to federated HPC services that exist so far. We need to start thinking about what comes next, in which direction Phoenix needs to go in the future, which services are needed, and which funding is needed and available.
Okay, so thank you very much, Anna LÜHRS, Maren FRINGS, and NAHM. Wonderful. So after this introduction, we have now the opportunity to ask experts about their opinion concerning federation, concerning Phoenix, concerning S3, etc. And I welcome 4 experts. I should first apologize that Anders Jensen cannot come due to the strike. So the strike situation has, of course, made it difficult for him to come. And so let me start with the person sitting to the left. This is Yannis IOANNIDIS, Professor Yannis IOANNIDIS from Athena University, leading the Athena Training and Innovation Center, the research center, yeah. So you are also the vice chair of S3, I'm informed, yeah. You was, but in this period, yeah. So, and you are also expert in setting up how infrastructures, how mathematical, let's say, elements come into research and how they are organized, research software engineering, etc., etc. Thank you for coming. Professor Lena ODEN from the Hagen University, also with us at the Jülich Supercomputing Center and responsible for the WP6, together with Steve Ferber, the compute infrastructure in the Human Brain Project, in the eBrain section of the Human Brain Project, to be very precise. So you are also someone who, from the beginning on of these activities, has accompanied it and know exactly the relation between the users and between the technological elements of the project. Thank you for coming. So Stefano GORINI, head of the operation team of the CSCS. You are one of the pioneers helping the Human Brain Project to start, yeah, with infrastructure services. Actually, the pioneer, because you worked with the Human Brain Project much earlier than any other center. Yeah? So the idea to federate essentially was born out between your center, between your boss and me. And of course, I should not forget Colin McMurtry. I remember very well when we were sitting in a pub somewhere in Frankfurt and had some beer and came up, we need something for federation because that's essentially what is important. So thanks for coming and thanks for contributing here. And Per Öster from the CSC, the Finnish Supercomputing Center, and also one of the heads of the big machine, the biggest machine in Europe at this time. This is LUMI. I think it is a snowflake is what it is, yeah? LUMI means snowflake, but it's not really a snowflake. It produces some heat, I guess, yeah? So it would melt down. And you are in operation, yeah? But you are not only that, you are very much concerned with the infrastructure development, the computational science infrastructure development, and you are also the hub leader of the EOSC in Finland. This is history, but you have been, yeah? Okay. So thank you for coming, yeah? Okay, so let's start. So we have as a first question, I have one to Lena. So, Lena, you are, as I said, deep in the, let's say, business of bringing compute to users, yeah? Especially also the OpenStack computation, but on the other side, on the other hand, also the computation with big machines, with HPC machines. So I like to call the federation idea of all of these activities which we need so that the user can just access these resources from any point, and any of those resources that are within the project, I like to call this a child of the HPP, because Phoenix was born out in the HPP, and I'm very proud that we could manage that. There was also a very important outcome of the project on this side. So you can certainly give us some interesting examples and some insight if federation actually has been achieved in this context. So there is a technical issue, of course, and also an application issue. So maybe you can a little bit comment on that.
Yes, so technical, I think we are very far. So if we have achieved it, I would say yes and no. So we are very far on the technical side. We have a lot of things. If you look like 5-6 years back, nobody would believe that this would be here now. We have a common interface where you can apply for compute and cloud resources on different sites at the same time, which is, for me, who's also an HPC person and like this machine's very great, because then I don't have to write 5 proposals to get access on 5 sites. I can just write 1 proposal and I get access on the sites. And I actually did this, but I will come to this point later. And we have this, the points which I mentioned before, like the firms where you can look at your resources and your allocations and manage your users from one side, from one entry point, which is really great and make life for, well, head scientists much easier, because then you can distribute your resources and can see what is working. The same is true for the identification, because then you can you don't need you still need an account, but you can use a single identification on all sides, and this is what you need to allow federated work. So from the technical side, we are now very far in the process, which is great. And now we have also these tools which are well mentioned, like the data mover and the data transfer, which allows you to transfer data between the different sites, which actually allow cross-site workflows. So we are very far, yeah. On the software side...
May I ask you, sorry for interrupting, but we heard before that more than 80 projects are running under this, let's say, technology. These are then those projects mainly that run on a site, or are these already projects that are running, let's say, cross-site-wise somehow?
Most of them are currently just running on a single site, but I think this also has historical reasons, because at the beginning, we had not the systems ready, like CSCS. But as I said, for example, I write a proposal by myself for co-simulation, and I actually asked with purpose for different sites. We're just on the development side, but we wanted to have resources in Jülich and Seneca, and so we are working. And from the software side, a new approach is also that we have this eBrain software stack, the same software stack for neuroscience applications on all sites. And this allows you, for example, to run something like the NEST simulator on different sites. And we have a lot of projects using, for example, NEST, which are running in Jülich, or which are running on CSCS side, also on Seneca. And with the same version and without a lot of changes. There still could be improved, and this is another discussion, of course, but it's working and people can use it now. And another thing is we have different kind of resources. We have cloud resources and we have HPC resources, which is, I think, a very big difference from stuff like Amazon, public cloud providers, which only have cloud resources. Maybe I can get also some kind of HPC, but we have this connection. And we had, for example, the use case from Neurobotics, which run a brain simulation on the HPC side, and on the other side, they had the robotics side on the cloud instance, which is really great. And like mentioned before, we have a lot of use cases which use the collaboratory in the Jupyter notebooks, which are running on the cloud resources, and you're now able to start your HPC job directly from the Jupyter notebooks on the HPC sites. And I just was in a workshop where you could see this learning to learn framework, for example, running on a Jupyter notebook, and then it just started, and you could actually choose the HPC site where you run on. So this is very great achievements, which would not be possible without something like Phoenix.
Thank you. I can just confirm that this is very well, let's say, adopted Also in the field of quantum computing now people start to use this technology, and at several sites one can just transfer from HPC to quantum and maybe integrate. So I think this is a value in itself already. Very interesting. So Yannis, I mentioned S3 before, and we are of course very proud that the eBrains infrastructure is on the S3 list, which is on the one hand nice. On the other hand, it's also of course giving us a lot of incentives to work hard. That's very important. Now, what does Federation have to do with S3? S3 is, of course, let's say just a name for many different infrastructures. They are S3 infrastructures. Would you see the potential for what has been created in HPP under Phoenix and IC? Would you see a potential for that to be adopted by 1, 2 more S3 infrastructures? Are they digital enough to do that, or do they have the needs for that, and would you appreciate it?
Short answer, yes. But let me elaborate on this. S3, it's European Strategy Forum for Research Infrastructures. It's a forum of funders from all member states, associated countries, and the European Commission. And the roadmap contains research infrastructures, either projects that are under implementation or those that have been implemented and now they're considered landmarks. Split in 6 categories. One in environment, one in health and food, one in energy, humanities, and I'm forgetting one, it'll come to me, and the digital one. And for the first 18 years or so, there has been only one digital infrastructure on the S3 roadmap, and that was PRACE. Everything else was in the other categories. Environment is the one I think I missed. And, but many of them, first of all, very few infrastructures on the S3 roadmap are single site. Most of them are distributed. They have different instruments or different sites where things are happening. And the focus is, as I said, the environment, energy, physical science and physics and engineering and so on. But many of them are crypto-digital. Their essence is digital. For example, taking Elixir, for example, it is, if I may say so, the flagship of the health-based research infrastructure on the S3 roadmap. And what is Elixir? It is purely digital. It's data and computations and so on. And like that, I mean, I can go into the humanities, DARIA, which is on cultural elements, and many others. So the e-infrastructure that, like Phoenix or EuroHPC or PRACE have, makes sense for all of them. And as our world, our society, and together with them, our science becomes more and more digital, more and more distributed, federated infrastructures like Phoenix. And Phoenix was, for me, was a pioneer in what it tried to do. Will have tremendous use, and they will bring the way science is done from other research infrastructures to the next level. And now, could Phoenix be a separate research infrastructure on the S3 roadmap that many of the others are using? I think PRACE here showed, even from the very start in 2006, I think it was in the first batch of the S3 projects, had shown the way. Yes, it can be done. And eBrains is on the digital side. It chose to identify itself more of a digital infrastructure rather than a biologically oriented infrastructure. I think that was wise, and I think the Phoenix part of eBrains can stand alone without any problem. So the next roadmap is 2025, so we can start working on that already to prepare an application for S3.
That's good to hear. We will see how finally the, let's say, the funding that we might expect in the direction of federation would allow for that. So there are probably different plans. Still, we see that there is an extreme interest from the European side that the federation of the big systems, including the environment, this means the open stack computation, everything that you need here is let's say, pushed forward. The real question I have, the other one, and I have asked it to you, is you might be aware that the big data activities are not under the regulations foreseen for Euro HPC JU. These are, for instance, the data lakes to come. What would you recommend what one should do in this direction? We know Destination Earth will be certainly a data lake issue, and there might be others. I could even imagine that the human brain activities finally, if we achieve a state where, for instance, this research leads to potential use in AI, etc., would need more or less data lakes, etc. What should we do now in order to get this achieved? So far, we don't see it foreseen. Of course, supercomputing centers will always have an accompanying data space. But when we talk about data lakes, we talk about those data that might be produced by SKA or really by the very big activities. What is your take on that?
That's a tough question to answer.
Actually, I asked it because Anders Jensen was supposed to be here, but now he cannot okay. reply. We will have to give him in written form afterwards. I'll
answer mostly as a data person. Most digital infrastructures are generic. Supercomputing, quantum computing, cloud, networking, and so on, storage, can be generic, flavorless. Everything can run on that with the appropriate software and so on. But when you go into the data level, semantics enter the picture. Okay, the storage part can be handled, and can be handled in the same way that we're talking about. But when semantics come into play, then the level of complexity is 2 orders of magnitude more on how to federate things, because you need to interoperate, you have to come up with various dimensions of heterogeneity, semantic heterogeneity that you have to deal with. Regulating that, harnessing that, or leaving this up to a federation that is purely generic, let's say in the Euro HPC layer, level, is probably something that is hard for me to see. I think you need the more specialized infrastructure, the more specialized environments, the data lakes, to come into play and provide their intimate knowledge of what this semantics is in order to handle that.
This means you would see it on the platform level and not on the infrastructure level.
Correct.
Okay.
Correct. Yes.
Stefano, you wanted to comment?
I wanted just to second what you said, because we had an example in the speech before. So data curation comes to play here. So it's at platform level. You need to add the metadata in order to be findable, reusable, all the FAIR principle.
Yes.
And that cannot be infrastructure. It has to be at a different level. Infrastructure has to enable it, for sure, but the data curation is very important.
So this means the curation has to become really a very important activity within the research itself. Yeah? It has to be planned in if you go for a platform, if you go for a community platform.
Especially if you go in the example you made before, SKA or others, you will receive tons of data. If you don't organize them in a proper manner, then you have a problem. It's like they are not usable. So it doesn't make sense.
Yeah, so we can just continue with you. I have also some question to you. Actually, you have one of the leading centers in terms of looking ahead, and I remember well in 2014 we had an evaluation there, and the data became of a very important, of high importance, how to handle future data activities and how to cloudify somehow the whole approach to supercomputing. And I think from this spirit, Phoenix finally emerged. Yeah? Now, if we have Phoenix as an infrastructure, on which level would you see it compared to commercial cloud providers? So if you take, I don't want to name one, we know all of them. Would Phoenix be comparable in quality or in ambition, or are there elements with the commercial ones that we would not be able to provide? And on the other hand, do we have elements that the commercial ones would not be able to provide? Certainly we have to see this in the light of that maybe the EU or the responsible commissioners certainly want to have something in Europe created, however it goes, that is, let's say, comparable and compatible with the commercial ones.
So definitely they are different. They need to be compatible. If you think of the cloud as an enabler for a good user experience, like they have been so far, this is why they've been so successful, because it's easy to use, then they are kind of similar. But the big difference comes that Phoenix doesn't hunt for profit, they do hunt for a profit. So they're not really enabling a federation per se. While we do, I really like the last sentence that one of the best awards said, scientists for scientists. So we are working for the science and not for the profit. Yeah. And the idea we have been working in Phoenix since the start is to find a common agreement, to make agreement across state, across centers, to enable the user experience of a cloud experience, but with in mind the collaboration across all the sites with different, I don't know, political agenda in each country or whatever, but to find a common agreement to go ahead and provide Europe with a cloud approach that is asking for, and scientists are asking for it. Then Commission, I think it's just the voice of scientists asking for it. And this is, so the big difference is what they are looking for, because if you go, I know, you can name Amazon or Google, if you stay inside, it works. If you try to federate and they are indifferent, it doesn't work. And you will spend money just moving data across. And this is one of the things we simply don't care about, because that's not the goal. We are scientists for scientists.
They just don't want to federate because of obvious reasons.
Yeah, it's clearly business. They don't want to federate. So it's completely the opposite on that.
Just one indiscreet question. Did all of this, what you have achieved here, have, let's say, an influence on your normal operation of your center, on the standard HPC activities? Was there, so to say, a change that is, or is there a change initiated here?
So for what we saw, at least at CSCS, it's been an accelerator on going in that direction. Because even before we got questioned by the state, saying, why don't we should invest in you or not in cloud? And we are showing them why, because we can do the same thing with, again, the scientist for scientists, a good marketing spot. And it's true, we are not looking for profit, so invest in your own centers, they can do, because at the end it's mostly open source. So we can tune, take all it, and we have shown in Phoenix, we are simply pushing the standards and defining standards to do cloudish operation. And that's, so it's just accelerating that process. I think it was coming anyway. It's not really changing completely the paradigm.
Yeah, but it is influencing the way of, at least at our place, we also see that the way to operate, to have the user access slowly changes towards the cloudification.
Well, if you think it's also pushing a little bit the user on doing slightly more things, because they have to act as platform guys sometimes. Someone doesn't want, so it's pushing us to do that work. And then you need to find an agreement who does what. So there is more this, we are shifting towards the cloud approach. But at the end it was coming anyway, so if you go down deep to the technology, the RESTful API approach that is at the base, it's what's coming. It's sharing, because RESTful at the end means web, putting things on the web. Yeah, sure.
Just ask another question in this direction, because do you know where it comes from? Because I also had this feeling when I became, especially with HPC, this approach and the user was not of interest for a lot of people, because I had this feeling in HPC and how you access machines and how you use this, did not change for a long time. So if people use it in the 80s, it was kind of still SSH access and so on. And I have the feeling in the last years, a massive change in this direction starts. And a lot of people and a lot of HPC centers also change their way, like you see this more cloudish approach. Why do you think, where does it come from? Is it from the user? And is it because other users are using HPC, like neuroscientists or machine learning? So what is your impression? Where does it come from? Why is this now finally changing, which I think is a very great development?
So it's a good question, because if I think we have both sides of the scientist, someone that doesn't want to go to the cloud approach and wants to stay on SSH and whatever, they don't care. But they have been HPC users since a long time. So new science fields are coming to use more HPC. And this is a good thing for our business because we can help them. Neuroscience is one of them. Because I remember in HPP Summit, I don't know, a few years ago, we were getting questions that typically an HPC user will never do because they were newbies in this field. So the cloud is helping people to approach more HPC resources. And then obviously, it's like when something is easy to use, it spreads like a virus if you want to. And then it's, okay, it's easy, why don't do it? And then you get questions also from old users that were not supposed to, I don't know, Jupyter Hub approach. Now everyone uses it, but a couple of years ago was for a little group of scientists or fields. So I think it's this way, but.
Yeah, so this means somehow the dream of having a unified form of access and to find all the services everywhere seems to be there, but it is really so. You as a as a new element, a new member of the Phoenix, I think since 1 year or so, you must have asked you this question: if I go there, do I lose my individuality as a center, or can I maintain it? What, for sure you have asked this yourself, and maybe you can tell us a little bit what it means now, in which way you achieve both, that you are part of the federation, on the other hand that you can maintain your access technologies and your way to operate the center, and maybe give some comments on how flexible the Phoenix and IC concept is in this respect. You also have your own access software, Puhuri, and maybe you can a little bit comment on this, would be very interesting.
Maybe I should borrow a microphone here, otherwise you can't interrupt me and then take over here. Yes, that would be very bad. So yes, this is an interest. So as you say, we joined the Phoenix collaboration here, was it 1 year, 1.5? It's a bit blurry here during the pandemic, how many years that actually passed. But of course, we have had we have a long collaboration before that. But and that, let me start from a point, because with this federation thing, it's also very important that the layer of federation is something that you actually can adopt to as a center, without changing the way you are working, without changing everything at your site. That is absolutely important. And I can say from that experience, we have Elixir was mentioned here before as a bioinformatics research infrastructure, and that is where we have been engaged for a long time. We are hosting the Finnish Elixir node, and there in the beginning it was a lot of discussion about federating of the Elixir services and Elixir sites. And the conclusion very rapidly, it started, it was heavy, difficult, intrusive and so on, and how can we get things working? But the minimal layer of federation, and that is to look on the authentication and authorization layer. Basically make sure that having the users, the researchers in focus here all the time, and making sure that they can use the same identity to access all the different services. That seemed to be the most important for the researchers. That and it is the same identity as if they are part of a European university, have given by their university because of their NREN, is using the federated identity that is supported by SHIAN, and then they can map it easily to an identity here at the sites. And that, with that, you have solved a lot of problems. And then you can need to add, because there are specific need in the human brain project, that the researchers here need more attributes connected to the identity. So you can actually be authorized, what am I allowed to do with this service? What data can I access? Have I the ethics committee approval and so on? And that need to be checked. So it's more attributes, but that can be handled, and we have an architecture for doing that, and it works. And the beauty with this is that I haven't checked, but I look to my right here. It means that any researcher from Elixir actually could access a human brain service, and vice versa, without any further ado. It's just that they have to apply and they have to be accepted, and they can make use of that service. And I think that is an enormous benefit, because we have the standards and that are in common here. And that answers your question. I feel no worries. We never felt any worries by joining the Phoenix collaboration because of this, that it's, let's say, a non-intrusive federation. We agree on the APIs, how we talk to each other, the language we talk to each other, and on the standards. So that makes it very easy and also very, very efficient in that sense.
If I may ask an additional question in this context. So there is a debate, it was from the beginning on in Phoenix, and it's still there. Where is, so to say, the boundary between the infrastructure, of course we can say API, and up to the platforms? So, okay, I can tell you my opinion, and then you tell me yours. My opinion is very often we would need the platforms to give some help to the platforms from our infrastructure perspective, in the sense of high-level support. Yeah. So in order to do that, you have to know a little bit about the platforms, what they do, what is Elixir doing, what is Human Brain doing. How far would you go here? So how many people would a center need, let's say, for a specific community? What would be your, let's say, feeling in this direction?
Yes, I think that is really our asset as being centers focused on supporting research. We talked here about cloud services. There are a lot of commercial cloud services, and you can set up a virtual server and you can install your thing there, but you are alone there.
Yes.
And that is the difference. What we can do and what we do all the time is to work to have our experts on the IT side work together with researchers to really meet the needs of specific services, and where they, because one have to understand today, and you're all as researchers working, there is really complex workflows involved now that need to access a database here combined with some local data you have, pre-process that, it goes to some cloud virtual machine, it accesses some other service, and then some kind of container is baked that it's submitted to an HPC machine, and something comes back, and you unpack this, and the virtual and the visualization is made, and then you are delivered a result finally. And in this is not easy to do. But or to set up, and you need expertise here, both from the IT side and from the research side, to really put down what are the requirements, what are the science you want to do that need to be translated to IT. And when you have this pipeline set up, and then it can be automized and running and be part of the daily routine and in your research toolbox, let's say, that you use frequently. But to set these things up, it really requires the expertise from the IT side and from the research side and if one get that expertise together, then one can be doing so much, do research so much more efficiently and take next step and so on. That's so important. That's my experience of seeing this happening so many times in different contexts.
It will require to put effort from both sides, from the center and from the community.
Yeah.
Yeah, okay, let us go back to Phoenix and maybe to the vision. I actually would want to ask Stefano next. Because you certainly have some visionary components also, because you were the first to set this up. And so let's now look into the future. If we look at all of this, do you believe, and you can say this because you come from Switzerland, do you believe that in this manner, finally, Europe can become a global data space? So my personal vision is, and maybe you can contradict, finally users or user communities will not just apply for computer time at the center and say, there's a queue and then I go into this queue, but they will specify parameters of their computation and they will be in some sense given a supercomputer or a data flow and data engine. Is this too much vision, or do you think this vision will come that finally we have all over Europe one big European data center of the future that finally can be used in principle by every scientist?
So I think it connects with the last part we were saying before, the data curation, and also to what Per was saying. So if the data centers are able to accompany the fields and scientists to curate properly their data, that doesn't matter where they have their data. We can work on tools and help them moving through Europe data, but just the part they need, because they know how to find it. They don't need to move the old block. So vision is, yes, it will happen. How long it will take, who knows? Because it's a lot of parties educating the community on treating well your data. But you can start with your phone. You take a picture, you don't know why you took it, or you cannot find it. It's the same. If you do an experiment, make your data through the FAIR principle reachable and findable. When you have that, then you can select. And selecting, you can accommodate with the speed you have on the network to move just what you need. And then like the limit between computing and data management is not fading, but it's becoming thin. And then you can apply whatever you want, and you can compute whatever you think.
Will people still program? So I read this, will people still program in the future? I read this other paper, and we had, of course, a discussion on artificial intelligence before and foundational models. This paper where they said the end of programming is reached. How will all of this be in the future? Will we just tell the system, I would like to, let's say, analyze some brain slices in the hippocampus, and please use this and this atlas coordinates or whatsoever? I don't know.
At the end, you can think in the reverse. Why people that are more scientists on neuroscience should code in a proper manner? They should use the computer scientists to code properly, and they being able to just touch the parameters and then have a good science in neuroscience instead of doing computer science in neuroscience.
But aren't you saying that we don't need computer scientists in the future if the artificial intelligence can just do this job?
No, it's impossible. You will need it at a different level, but you will need it. I think the speaker, the keynote with the ChatGPT made it clear. The artist that was saying, yeah, but this is not really art. It's the same.
I hope it's not wishful thinking.
Yeah, it's wishful, but
okay.
As a human, I hope for that.
But maybe some of this will come. If you want to comment.
When computers started, the programmers were programming in machine language.
Yes.
And for the past, 60 years, 6 decades, the effort is always to abstract and have a more abstract language so that we don't go in the lower level. The current status of ChatGPT writing you Python programs and SQL queries and so on and so forth is one layer that we achieved. Let's not forget that the ChatGPT software a human has to write. It's not self-writing. Yeah. And I believe it's just a step, and there will be even more abstract and more abstract. So I don't think that computing scientists will disappear. But one of the achievements that this field has reached is to make it easier for non-computing people to compute or to express what they want. So ideally, yes, they should say the parameters or other parts, and then the software developed by who knows whom, natural intelligence or artificial intelligence, will be doing what they want. In a database field, SQL succeeded because it gave a way for people to ask what they want and not how to get it. Yeah. Whereas procedural languages have to say how. Well, now in even more computational areas, beyond just data querying and so on, we're getting there. And I think we will achieve it. Yeah.
And I also think there's a big difference between coding and programming. And I think coding hopefully will disappear. But programming, then you can do so much more if you don't have to care about the coding so much. You can, I think, make much greater things if you don't have to care about the details anymore.
So you would think that that programming will be maybe visual programming or a sort of meta programming?
Telling my ideas and...
even with language, even with just with language.
Yeah. I think you still need inspiration, you still need an idea what you want to achieve, and now you don't have to, maybe the step of translating this into code becomes much more easier, and I think this is a great achievement.
Maybe that's exactly what I meant.
But you have example, for example, in iOS programming, now it's a drag and drop programming. So you want an array, you drag and drop, and then you drag and drop the image you want into the array. This was not the thing I was doing at the university, definitely. So from this, then you go to what Lena was saying. I will think and it will come, but you need a mind behind.
Yeah. Okay, this was a little bit of discretion, but it has very much to do, of course, with what we can expect. So let's discuss a little bit further even and go into the questions that might, let's say, concern the young people. Are we now, after so many years of computational science, especially, and I ask Lena, because you have to deal with young people very often, certainly, are we now, after so many years in computational science and 10 years Human Brain Project, etc., in a state where we can say we have achieved such an integrative position, or let's say a profession, like a data scientist that also is a neuroscientist at the same time, or part neuro, part data scientist, that this, let's say, people are accepted by the respective computer scientist communities as well as by the neuroscientist communities? Or is this still an exotic thing? And what would you tell the young people who feel that one should do this and should become a neuroscientist plus a computer scientist, because we are going into the digital age? I feel that you are teaching such people, but what do you tell them?
It's a very difficult question because, well, if I look into the close future, and I think computer science is not it always needs something where you could use it. So it's definitely necessary to have a use case, and neuroscience is a very interesting one and an approaching one, and I think we have learned a lot of each other in the last years, because neuroscientists were new to HPC and computing in a few ways, and I think there's a lot of ways still to go to be optimized, but I think it's a very nice use case, and I always recommend people to be able to work in different disciplines and to be able to talk to people, because well, just to program something will not solve any kind of problem. And if you look into the future, and I think the problems of the future cannot be solved by a single discipline. You always need interdisciplinary work, and therefore I would recommend always people to be able to talk to each other and to be open to this. On the other side, in my dream world, and if we look in 20 years into the future, a real neuroscientist should not care about the programming and the language beyond. So in my dream world, if somebody wants to make an experiment, wants to get a setup, he just clicks, builds his digital brain model, and then run it on a supercomputer. It's working, and this person does not have to care about the compute beyond and how it's working. It's just working, and he gets his or her great simulation results. But at the moment, we are not there. So if people are interested in both areas, I think there are a lot of opportunities in research, and I think there's a lot to come in the next years, and we have great programs like like Arbor, which are going to this HPC area, for example, a great software project which is running an HPC for neuroscience. But there's still a lot of work to do, in my opinion, to be real, but it's accepted. And we have now nice publications in this area, and we have now good research areas. So if you're interested in neuroscience and computer science, if you want to become a big researcher, I guess now it's the best time to do this.
Okay, please.
Yeah, one comment to this, because it's been a lot of movement and talk now. We need data curator, data scientists, and so on, and that should acquire these skills. And I'm not, yes, to some extent, one need that. But looking back and see how it evolved when computing got widely spread into more and more of the research areas. Already in the 90s and early in the 20s here now, where a lot of PhD schools in computational science, for example, were a tool that was used in many places. You invite young PhD students from various areas come together in a specific PhD program to learn computational science. And I think that was very good. But what you see, how is it evolved? I don't think there are many of these PhD schools in computational science around anymore. Yeah. So what have changed? It has become a basic knowledge that you are gone into the university curricula, or it is a skill that we as computing centers have really good training for people. And you to take the courses, you take the training, you learn the bits that you need, and that's fine, yeah. And so it becomes this kind of skill that every basic.
So would it mean that it takes care for this infrastructure, like the federated infrastructure? So we need people in the future. We need in a diversity of elements of the infrastructure, curation. We have to have those people who can do really the basic API programming, etc. Do they have a chance in an academic career, or is it just a technical profession?
It's actually very complicated because, at least in Germany's universities, move sometimes very slowly, and they very often still think in disciplinaries. So you have computer science, sometimes you have economic with it, but it's very difficult for them, I guess, sometimes to look left and right, to be honest. But I have this feeling on the other side that this is also starting to change, because now more young people, like me, are coming. So I see it in my faculty. If new young people come, they're more open to this. So I hope this will change in the future. And we are forced to do this, because otherwise we will not go further. And there's one side that I think, in my opinion, at the moment, as long as we still need programming, everybody should be able to program, and it should be part of every curriculum. And I think a big part for the German universities, I'm not so aware of Switzerland and Greece, should go away from this faculty thinking and allow more interdisciplinary research. But at the moment, to be honest, I see this from other people, it's still very difficult, and a lot of new professorship and new positions are still very disciplinary, which is, in my opinion, a big problem. And if we don't change this, well, I think it's not the best time for further research, because then we cannot solve the big problems of the future.
I have to look for a country who's doing it better than Germany.
Everywhere in the world, the universities are divided in faculties, and I don't think this will change anytime soon. But at least in the US, and now from my ACM presidency experience, I'm talking about when it comes to data science, which is truly interdisciplinary. I mean, computing and statistics and some other domain discipline come together in order to do data science. A university may have 10 different types of data science programs that are given by different faculties as they interact. So the structuring and the governance of a university may stay disciplinary, but more and more I see, definitely in North America, and I think it will slowly or faster will come to Europe as well, where we'll see these interdisciplinary elements as programs. So a student is not attached, or maybe they are attached to some faculty, but the degree that they get is interdisciplinary. And this connects very well with what you said, Lena, before. Neuroscientists should not have to program or code, two separate things, which is true. But in order for this to happen, we have to have software that has a lot of neuroscience understanding, in quotes, in it. To develop these programs, you need people who are computing people and are neuroscience people. And this is true for all other domain scientists. And this interdisciplinary knowledge that can come from a group or within one person if they have multiple interests, I think it's the foundation of the next breakthroughs in science, because the most interesting things now are the seams between computing and, well, not some of the most interesting things are at the seams between computing and what the disciplinary element does. And more, I see, even if we focus to computing people, generic computing people, I think the group will shrink. People that only focus on computing. But interdisciplinary computing people will grow to the very disciplines. And that will be the great demand that we'll have in the future.
Yeah.
I can comment that because I think there's something very important mentioned here, and that's where you take the step from doing research to support research. Yes. I mean, and that is difficult to do in the academic world. But it's so, I was thinking of it today here because one of the presentation of the best abstracts here was mentioning this, that yeah, we support research by what we are doing, yeah? And yes, and to some point you can do that as research, but at some point it is not research anymore. And continue this line within the university world is usually very difficult, because if you are not part of the academic staff, the career is limited there. So there, I mean, I'm lucky, I work in an organization that is specialized on supporting research. Yes. That's what we do. We have a career path here inside the organization, and we have a number of researchers that come and work with us and take this step, moving from doing research to support research, but work very closely with researchers. But it really requires organization and that you can set up this and understand that it is a profession in itself, yeah.
I understand.
Adding on, because before you asked if there is an academic career, with at least the experience we are doing with the university in Switzerland, there is not. We really miss also the basic bachelor training people to code the API, as we would love to have support for research. So we are doing that. When we hire junior, basically we spend most of the time training them. So we do that part, but I don't think they have, at least at the moment, a career part in academic. We does, but we are not academic.
I guess without that, all plans to go for what we had discussed before and our visions will be difficult. Yeah, we have finally to give those people a status that corresponds to the importance of what they do. But let me go further to some philosophical issues. Maybe I'm a little bit too fussy here, but Europe in itself is a federated sort of state thing. Yeah. So we work together. We have a sort of, let's say, commission, but not a government, if you want to say so. Finally, this is controlled by the national states, but it is federated. Let me turn it around now. We have then also a specific spirit. Would this spirit of federation help us to make federated infrastructures something that is unique in the world, that is for us much easier to achieve than maybe for any other country or any other continent, because we already have a political federation of 27, I think, countries? Would this be an idea, and could this be put on the agenda such that it provides finally an added and even economical value to Europe that we could use and could be good for us?
So I start because I'm from Greece and philosophical questions.
Yeah, this was the reason I put you in the let's say, genealogy of Aristotle. Eh?
Yes, yes. Wow, great weight on my shoulders. Again, the short answer is yes. And I think in the, again, many decades of life of the European Union, we proved that things can work and we can achieve things. And federation, if you want, is a particular form of collaboration. And that's a value, it's a virtue that you don't necessarily find easily in other parts of the world. And Europe is a leader in that. I'll come to some negative things afterwards, but in the principle is that Europe has shown a way to do things together. And even in the research infrastructures that started 21, 22 years ago, ESFRI started then, we are the leaders in the world. Other regions of the world are looking to Europe to see how it is done. And maybe the US or China doesn't really care because they can do it on their own inside their big countries. But Latin America, Asia, Africa, even Canada is looking to Europe on how we are doing this so that they can not replicate it, but at least adopt it. Yeah. And this collaborative, federated spirit, I think, permeates the infrastructure. And for example, open air and how we deal with open science in a federated, distributed way is also, we are leading the world in that, and the world is looking for us. So if Europe was the United States of Europe and was not the European Union the way we know it, I don't think we will be as advanced in learning how to collaborate. Let me say, but let me say two things to add to that. This means that it takes us so much longer to do things. And honestly, from my perspective, even in this collaborative spirit and everyone has to agree and so on and so forth, we can do things faster. So there is bureaucracy that is not inherent to federation, it's not inherent to collaboration. We can get rid of some of that and move faster, and this will be an even better model for everyone else to see. So that's the issue of speed and the bureaucracy is something that really hurts us and hurts science, hurts research infrastructures, and so on. And the second, the issue of sovereignty, the data sovereignty, the technology sovereignty. I think, yes, we are federated and we are collaborating, but the European sovereignty is not yet instilled in us. We are still national, our national sovereignty is much stronger and leads the way in our decision making. I think if we all, as fast as possible, we get to European sovereignty, then I think together with the values that we carry, that of the value of the human, as opposed to, again, North America or China or other parts of the world, I think this will be paradise, including paradise for science.
Thanks for that, Per. Let's go back to some practical thing. Now we are 6 sites that drive Phoenix, but in order to get a true European, let's say, federation, we need also the others to come in. Do you think this will be easy, or they will just come in? Or what would be the spirit to get them happily joining us?
You mean spreading the use and the Phoenix research infrastructure and the participation?
We have more than 6 in the future, 6 European sites. Yeah.
Yeah, it depends on the offering, of course, and as the offering is good, it should be easy. But there is always a, of course, well, it is footwork, talking with people and show the benefits and what is there to gain, and that the combination here this experience that we get so much further if we work together and do these things together, that we have seen, and we can see the examples from all over the place, really. So from that point, I'm optimistic on that. What you always have to look into then, how do you do with governance and steering, and what involvement means here, because you could have different levels of involvement and engagement and so on. And that is a question now when we are a small club in that sense. We have not cared so much about it, too, honestly. It's easy. We are friends that meet and solve things. Yeah, yeah, very simple. So that are things I think that we have to look into also for the future and present this, so people see to join that there is a stable structure and a sustainable idea behind it and structure behind it. Yeah. That others also can participate in and influence what are the directions and so on. That is clear, I think, for the future.
Thank you. Our time is quite advanced, but I think we would have time for 1 or 2 questions from the audience, if the audience would want to comment and has some urgent idea to express. So any question? If you have a question, just come down. There is a microphone here. Yeah, thanks.
Yes, hello there. Thanks for a very nice discussion. I just had a comment on these boundaries between universities and computing centers and any other institution. And also speaking to the discussion about curation as an important activity and where should it be located. So the reason curation in fields like neuroscience is taking place in the academic world now is that it would not be established at all if it happened outside. You have to be in the middle where the research is going on. And there are tons of problems. The curation service part is a small one. You have all the ontology developments, you have to set up metadata management systems that connects to real world science. So academia is probably the way to start, and as things evolve, these things might move into other institutions. And here again, we speak a bit about boundaries between disciplines, boundaries between institutions. We need to break them down as much as possible. Any thoughts on that in relation to how to continue?
I think it was a good comment, actually. So I would fully support that, and seeing it as an answer already to that we should have that. So, okay.
May I say something to Yannis?
Yeah, of course.
Yeah. Universities are fermentation grounds, and absolutely that's where it has to start. But when the profession of data steward is established and data infrastructures become on an equal level as other infrastructures, then I think the university is not the ideal place. It has to move somewhere else. Establishing in everyone's mind the concept and the profession of data curator, data steward.
I think
So I have another question also relating to boundaries and sort of who should do what. I think one of the really exciting developments that has come out of eBrains now is that you can run complex things from your web browser on the eBrains infrastructure. So we had a beautiful example yesterday with the Learning to Learn workshop here. We have, for example, Nest Desktop as a graphical tool that you could use in teaching neuroscience. But then if you want to use that as a teaching tool, the great advantage is none of your students need to install the software. But if you have let's say, a basic introductory course in neuroscience, 300 undergraduates, and they should do 1 week of computational neuroscience. Things need to work when you're standing in the lecture hall. And then the question is, how many nines do we need in reliability to offer that? And how many nines does it make sense that a research infrastructure offers? And where do we have to say, okay, if we want to offer this as an educational product, we need 4 nines. For research infrastructures, for many reasons, only 2 nines make sense. So we need to move somewhere else. Where would you see those boundaries? How far can we go as research infrastructures when it comes to reliability, so that someone who wants to use our service can really trust them enough to go out in front of 300 students and say, you open your laptops now and push these buttons and be sure it works and fails once a decade.
That's a sort
do
of
we want to do
requirement.
that, or do we have to go then say, okay, that's something that commercial providers can do, but I think we need to reflect about that to see where we head.
That's a requirement that, of course, we have to reflect. Yeah. So, any comment here?
Yeah, I can comment this. So I mean, this is something we do. This is a service that we actually offer. If I talk in my own center here, CSC IT Center for Science in Finland. So we have a lot of these classes. Our resources are used in this way also. And of course, it requires that you are, I mean, in control of the whole thing. Mm-hmm. And actually, but this is also a way how you set up this. And there I come back to how is this organized in different countries, in different places, and so on. I mean, we are, in that sense, a professional IT organization. Mm-hmm. We sell our services to the Finnish government and to the Finnish universities and higher education institutions. And, I mean, if they pay for this, we have to deliver what is agreed in the contracts. Yeah. And otherwise they don't buy. So it is as simple as that.
So you just fulfill your obligation.
We fulfill our obligations.
May I have
and that makes it may sound very easy, yeah? But it is of course not. But I think when one move into this, and as you say, one move from this being a research project-driven service to a professional-driven services, it is a step there. Mm-hmm. And both things have its place, but it also comes with different costs. Yeah.
So adding on that, because we had this discussion already yesterday, so I can take this discussion here as well. And this connects with the federation concept. So what we have done with Phoenix, and we agreed on that yesterday, we are providing, also leveraging eBrains, an infrastructure that through eBrains you can run on multiple sites. So the availability of the site mm-hmm. is becoming less an issue. So then it's a matter of discussing service level agreement. But that's different because as any cloud, if you have multiple sites, it's easier to stay up 99.99999. So here Phoenix helps, and the federation concept helps, and it's already helping. And so we can go from, because we do as CSCS the similar thing, but for research or science, it's much easier because you have to pay less and leverage federation to do that.
Okay, I think this answers the question. Thank you very much here. We have just now to go forward in time before we went backward in time. Now let's go some years forward in time.
So great to see you again. You know what? The other day I realized that it's already 10 years since the HPP is over.
Hey, oh, you're right. If we had only known how far we would get with Phoenix.
Hello, oh yes, I mean we were of course hopeful and enthusiastic that the infrastructure would still be in place, but we have achieved so much more than just maintaining it.
Yes, you're right. Who would have thought that we would have a fully integrated European computing environment in place, which can be used, of course, for the usual everyday work with computers, but also for large jobs on state-of-the-art supercomputers in the same way.
Yeah, what I like most is that it is all so easy to use. Joint calls for resource proposals, accounts are linked through the Phoenix AAI, Jupyter notebooks can be used for any of the services.
And scientists can also use other European clouds, like the European Open Science Cloud, in combination. Luckily, we managed to get the integration with them in place.
Yeah, it feels almost as if all services are offered by the same provider. The boundaries between partners, countries, initiatives are hardly visible for our end users.
Exactly. With the European data infrastructure being implemented, accessing and processing of large datasets stored in the cloud at different institutions in Europe is not a problem at all. And the services have been extended and enhanced so much.
Looking back, it feels a bit strange to know that all these important cloud and computing initiatives were working separately. A single European data and computing infrastructure just makes so much more sense.
Yes, you're right. So let's have a drink to celebrate.
Yes, and I should add that we are actually working on zeta scale machines and we are looking forward to iota scale machines. Thank you very much. Thank you very much. Thank you all very much. This was a great panel. Okay, I think with this session is closed.